Vector form of equations. Before applying a numerical algorithm to the governing fluid dynamic equations, it is often convenient to combine the equations into a compact vector form. For example, the compressible Navier-Stokes equations in Cartesian coordinates without body forces, mass diffusion, finite rate chemical reactions, or external heat addition can be written in the following form: du by dt plus de by dx plus df by dy plus dg by dz. Here u, e, f and g are vectors given by the following expressions: u e f and g. The unknown vector is u, and the equations are described by this vector. The solution is given to get this vector. The first row of the vector 1, 6, 2 corresponds to the continuity equation as given by equation 1.14. Likewise, the second, third and the fourth rows are the momentum equations, equations 1.34, while the fifth row is the energy equations 1.43. With the Navier-Stokes equations written in this form, it is often easier to code the desired numerical algorithm. Other fluid dynamic equations that are written in conservation law form can be placed in a similar vector form. Vectors E, F and G are contained of two parts: inviscid and viscous, and the inviscid flux consists of two physically distinct parts: convective and pressure fluxes. The former is associated with the flow advection, so-called advection speed, while the latter with the acoustic speed, or respectively classified as the linear and the non-linear fields.